Hello, so we'll talk about SimfiaNeo, which is a desktop application for dependability studies. So first we'll have a few words about what is dependability, just in a few words. Then we'll talk about some functionalities of SimfiaNeo, so you can see all the philosophy, the methodology which is behind. We have a short video of demonstration of the application, so to illustrate it. And then Yann will talk more about the technical points behind those functionalities. So first of all, what is the domain and what are the stakes? We are talking about dependability. So the societal definition of dependability is that for system, we need to have a justified confidence in the service or the functionalities provided by the system. Justified confidence, so we need to prove it. In terms of our engineers, it means we will be talking about failures, mainly failures of equipment or functionalities, and we want to assess what are the risks, what are the consequences, are they acceptable, and how can we reduce this kind of risks. So the main keywords for these topics are about reliability, availability of functionalities, maintainability also, and safety for our systems. Dependability studies exist for several decades now, and they can be performed with two main methodologies. The first one, which the classical ones, historical ones, is with fault tree analysis. We start from the field situations, field events, field situations of our system, and we want to analyze how it can happen, linking it to the basic equipment failures. The second approach, which is the one we promote through our tool, is the MBSA, the model-based safety analysis. So with the model-based, we want to model the system, model the behavior of our system of interest. And from this model, we compute the RAMs, the dependability indicators. So we are, for the functionalities of SimfiaNeo, we have it organized with three main pillars. First pillars being helping to model, helping to build the model of the system. So when we are talking about the model-based safety analysis approach, we are using formal languages. And here we are using a language called AltaRica. AltaRica, so it's a formal language used to describe a system, and it uses the notions of state automaton. So we put state automatons in what we call bricks. It's the boxes in our diagrams. We have state automatons, and then we link all the equipments with each other in order to build the architecture of our system. AltaRica, however, is a textual language, which is not always user-friendly for safety engineers, dependability engineers. So when we want to describe a system usually is a system, subsystem, sub-subsystems, down to the basic equipments. So it has a tree structure, and with the AltaRica language, you find this notion of tree structure on the right part with some AltaRica keywords, but this is code, and end users sometimes do not want to see code. This is why in the application, we have the graphical modeler, and we find on the left here the Sirius Model Explorer, where you can find the tree structure of the system. And you see in the center part, so Sirius diagrams, where we can instantiate equipments and other structures with subsystems. Then in our model, we put the behaviors, so like the state automatons. So again, in AltaRica language, there are some notions about transitions in state automatons with events, with laws, with conditions, effects, and all of these are linked to special keywords and syntax in the AltaRica code on the right. Again, the aim is to ease building for users. So here we use the if properties view with dedicated tabs for different parts. And here, all these AltaRica keywords and expression, in fact, are separated in dedicated fields, dedicated drop-down menus, etc. Then in our model, we need to put not the behavior like state automatons, but behavior like how values are propagated from one brick to another, or between relation between inputs and outputs in a brick. So this is what we call in AltaRica assertions. Typically, it's logical equations like if then else, Boolean conditions. And so again, you find some AltaRica keywords and special syntax in the language. So for translated for our users, in the interface, we find some still in the if properties view, we find some Xtext fields with auto-completion feature with syntactic checks. And to link elements, bricks, nodes with each other, we use the Sirius diagrams. And last point about building our models, we have what we call in our field observers, which is how do we define the feared situations in our system. Feared situation between, of course, it's ways when you have some accident, when some functionalities are lost, and we need to define it linked to the model. So again, it's in AltaRica language, you have some dedicated keywords, dedicated syntax, not always easy to use for basic users. So you have the equivalent in SimfiaNeo with interface with some, here it's a net table tables with drop-down menus and associated properties view with Xtext fields, auto-completion, other kind of features. So this was the first pillar about building a model. Then we have the second pillar about validation. If we want to have confidence in the results of our model and of our system for computations, we first need to have confidence in the model itself. So we decided to develop some tools using, again, some Eclipse and Sirius properties. The first one being checking some consistency. Basically, it's like, will I be able to compile the AltaRica code of my model, my system? It's this kind of questions. So in the SimfiaNeo interface and different views, we have, when we want to check if there is an error, we have a dedicated validation report with all the details. But then we have some markers in the model explorer, in the Sirius diagrams, in the if properties views, down to the exact place where the discrepancy, the error was detected, in order to ease validation and finding errors for end users. Then we also developed other point of views for users. If we take AltaRica expressions like if then else, or sometimes several ifs that are in the same expressions, they can be quite complex and are quite complicated to understand for external reviewers. So we decided to also have other ways to visualize them. So here it's generating equivalent truth tables with AltaRica engine. We'll talk later about these AltaRica engines more in detail. And then last tool I will tell you about for this validation is the simulation. As I told you, we have a formal language in order to be able to compute AltaRica model. So we have a dedicated simulation perspective, this time in Eclipse, with dedicated views. So we find here on the right the variables views, values of all variables. We have graphical views with, again, with Sirius diagrams that Yann will talk about, these views in the simulation. And also the list of events, the transitions that we are able to launch at one point in the simulation, in the model. First pillar, building the model. Second pillar, validating the model. And then, of course, the third pillar is about exploitation. Exploitation will mean computation, of course, but also going further with the results. So the first part is about computation, and the main kind of computation we want to do when we are performing safety studies, which is part of dependability, is generating the scenarios which can lead us to the field situation. So we have the AltaRica engine. We'll see how it communicates with the rest of the model. And it will be able to generate a list of results that we'll be able to store with the project and the link with the project and compute these scenarios and the associated individual probabilities. But we do not stop here. We want to go further on these results. And this is why we developed also dedicated sections in the properties views, where we embed some net tables for statistics on these transitions and some HTML dashboards and other kind of indicators that can help the analyst have another view of its results to help analyze all the information. Then we have a second important kind of computation that we can do. It's more about availability, reliability studies. It's Monte Carlo simulations. So basically, it's launching a great number of simulations, like 1 million, 10 millions of simulations, to compute numerical indicators. So again, we have the dedicated engine. We'll see how we link this to the model. And it will give us the results and also some graphs, again, some HTML view graphs, in order to help reading these results for the end user. And last point about it, at the end, all our safety and dependability engineers will need to generate some reports, some documentation about their studies. So here, in order to generate these reports and to help building these reports, we use the M2Doc technologies, which enables to fully customize templates. So each company, each services in the company can have its own dedicated templates linked to their specific needs and retrieve all the description of the system. Now we'll show a small video presentation. So this is SimfiaNeo with an empty project here. So when we first create a small project for you to see this Sirius diagram we use. So we use the palette, of course, and you can build bricks, which will basically represent equipments. Then you build links between equipments, between the bricks. And inside of each brick, you will be able to input the state automaton and the assertions I told about. So some AltaRica logical expressions with auto-completion features, for example, and live validation. Is my expression understandable from SimfiaNeo point of view? Of course, this can belong for a big model. So here we demonstrate that we can also import models that would come from the model-based system engineering teams. Typically, a model built from Capella, here's the in-flight entertainment system, and we import the physical functions of this Capella model. It will automatically compute the mapping between objects in the Capella model and objects in SimfiaNeo in order to rebuild, if you see on the left in the Model Explorer, the architecture of the systems. And you see in the diagram on the right, we have all the links between the physical functions, which are the information that are exchanged between them. And of course, we retrieve the names, but also the descriptions, other additional information from the Capella model. And then the dependability engineer still has to input the dysfunctional behavior linked to its specialty, the dependability studies. But this can greatly help launching and initializing analysis with this kind of import from Capella. Now we switch to another model until the end of this demonstration. It's a simple model where with few equipments. And here we want to validate this model. Do we have some errors? And here, yes, we have some error. We have a validation report with a detailed explanation. And if we double click on it, it will directly open all the right views to point to the specific place where the error takes place so that the user can directly fix it here with auto-completion feature. So it is navigation also in the model. Now the model is correct. We are able to simulate it. So we launch simulation. It switches to the corresponding perspective where we find in the center part the Sirius diagrams of the system, on the left the possible events, on the right the variables in our system. And from here we trigger transitions from our state automatons. It directly updates the diagrams and the variables views on the right. All these views can be filtered to see only updated values or all values from the model. We can also launch a transition from the diagram directly with the contextual menu. So it's again graphical tools like this to help reading by the users. Now that we have simulated, we'll see the computation part. We're computing cuts, so scenarios that links to our field situation, here erroneous output. And we see that the status of this computation is not up to date. It knows it and we need to launch them. So we launch it, we get a big list, a number of scenarios that link to our field situation with associated probabilities. And here maybe we think, okay, I do not meet my dependability objectives. So I will modify some numerical inputs from some failure rates. So here I will try to have one of the components more reliable. And if I want to relaunch the computation, it tells me, okay, the cut set, the list qualitative result is already good. I only need to recompute the numerical probabilities, which is important for Yann parts afterwards. And here we have the updated probabilities. And of course, all the statistics, the bottoms that have been updated. So now that I'm happy with my computation, I will create a new version of my system, a new baseline that I want in my history. And I will compare it with the previous version at the beginning of the video. So here, directly, it computes the delta. So yes, I changed an assertion. It's the error that we fixed. And I modified a numerical value, the failure rate of one equipment. So it's this kind, we use this kind of different tools from the Eclipse environment, Sirius environment, to help the user in their model. And now I will switch to Yann for more technical points.
Thank you, Xavier. So I will focus on some technical parts of SimfiaNeo. So first, we needed to reuse existing components. So SimfiaNeo uses Eclipse modeling framework to design AltaRica concepts, Sirius and if to show and edit these concepts. We use M2Doc to generate documentation or Xtext to edit and visualize AltaRica expression. But we miss a component to execute AltaRica code and to compute cuts or execute Monte Carlo simulation. So SimfiaNeo is not a big bang. Apsys develops model-based safety analysis software since more than 20 years. The previous software was called Simfia, and it is able to parse an AltaRica file, and it embeds an AltaRica engine in order to perform execution and computations. Simfia was developed in Java, which is integration with SimfiaNeo. We have cut the AltaRica engine and put it in a jar file. Then we have developed an AltaRica generator using Axeleo and a little facade API to interact with the Simfia AltaRica engine. We bring all pieces together and the result is plugged into SimfiaNeo. So now SimfiaNeo has an AltaRica engine, so we can add the step-by-step simulation feature. How it works. SimfiaNeo generates AltaRica code from the model. The generated code is sent to the AltaRica engine, which computes the initial state of the system. The state is all variable values. we show these values in a dedicated Eclipse view. It is just a tree viewer. And we put these values in the model of the Sirius session. When the model is up to date, Sirius provide a visual feedback of this model. We exploit Sirius conditional type to help the user to understand the state of the system. These styles are defined in the design file in Sirius to customize images or colors. Finally, we have another Eclipse view which shows all triggerable events which are provided by the AltaRica engine according to the state of the system. The user can select an event to trigger. Here, the user selects the engine 1 fail stop event. This event is sent to the AltaRica engine, which computes a new state of the system. And here you can see that all modified values have a yellow background. Sirius updates the diagram according to this new state. Here, the user can easily understand the consequence of the event. We see computer 1 is not able to provide data because it is not powered, but the system is still online thanks to computer 2 and computer 3. The list of triggerable events is updated, and user can select new events and so on. So SimfiaNeo have a dozen of tables to input data, to input and visualize data. And obviously, we have started to use Sirius tables. Using Sirius tables allows us to quickly deliver a first version of SimfiaNeo. Thanks to the design mapping file, it is easy to create tables. It costs only some man-hours, and it provides a lot of features to visualize or edit data. It also has a CSV export, and it provides a tree structure. But we needed more customization, like content assist in sales, custom filters which can be enabled using a simple button, or column filtering, column ordering, changing the line 8, and even have an embedded custom editor, an text editor in Cell. So we started to migrate tables to NetTable. We were able to do what we want, but it came at an expensive cost. It was also hard to do because NetTable API is very different than JFace Viewers API. And obviously, it is harder than using AQL expression in the design file. So despite not using Sirius tables anymore, we still benefit some Sirius capabilities. Our custom editor is plugged into the Sirius editor API, which allows to tell Sirius that an editor is linked to a specific Sirius session. So we have, for free, we have undo redo, save, auto update of the table when the model is modified elsewhere, for example, in a diagram or a properties view, and the editor is automatically closed when the underlying session is closed. So all data are not stored in the semantic model. We have some data in a database. I will explain why. So as you've seen, SimfiaNeo is able to compute cuts from AltaRica. Cuts are computed from an observer, as there can be tens of observers in SimfiaNeo project. For each observer, the computation result history is kept. There can be tens of computation results. And each computation result is a list of cuts, and a cut is a set of events. And there can be tens of thousands of cuts in a result. So it represents millions of cuts in a single SimfiaNeo project. So it is a very large number. If those results are stored in model, it will slow down loading, saving, and model traversals. Results are never updated, they are read-only, and we only needed them when we want to consult them. Sirius loads the entire model in memory, with exceptions in case of controlled resource. So if we store the result in the model, they are fully loaded in the memory until the Sirius session is closed. So it is a waste of resource. Even if we store the cuts outside the model, so in a database, we still want to keep the link between them and the SimfiaNeo model. SimfiaNeo is able to compute a global probability from cuts, and this probability depends on law defined on events in the model. Here we can see two computation, and SimfiaNeo knows cuts are up to date. But the probability must be recomputed because the user has changed an event law. When probability is recomputed, SimfiaNeo loads the previous result. It retries all linked events and recomputes the probability of the feared situation. On the top left corner, you can see a list of cuts loaded from database. The first cut has two events, which are backup computer fail erroneous and engine 2 fail stop. And we want to link the events in the cut, which are in database, with events in the model. Here it is illustrated with the table displayed in the bottom left corner. So each element of one cut is a row in a dedicated table in the database. Then each row is linked to a row in a table which represents our elements coming from the semantic model. And the model ID column represents the technical ID of the element in the model, so we can retrieve the element in the model. It also has a column to store a label, which is very useful when the element is deleted from the model and we want to display it to the user. So here we have the full path from events in one cut to events in the model, so we can retrieve the law of the events. So with this mechanism, SimfiaNeo is highly reactive despite the million of cuts. To conclude, using Sirius and other modeling technologies allow us to provide the first version of the tool very quickly in 2018 for development started in 2017. The development of SimfiaNeo has been focused on business features with almost all technical features already covered by open source components. For example, Eclipse provides good foundation for a desktop tool. For example, flexible workbench layout, preference management, help system. EMF provides tooling to define our AltaRica concepts. Sirius provides means to visualize and edit these concepts. Axeleo to generate AltaRica or text, and Todoc to generate reports. So Xavier, if you have some words to end
yes,
this session.
It enables providing the industry with user-friendly tools for dependability engineers which are not used to seeing code and things like this. And this way they can deploy MBSA in their companies in a very efficient and fluent ways compared to the classical methodologies that have been existing for many years. So thank you for your attention, and now it's time for questions.
Thank you, boss, for your presentation. And well, we have a lot of questions actually, and not so many time to answer it. So let me just pick the most rated one. First question: is the assertion language based on OCL or created from scratch?
No, the assertion language is based on AltaRica, which is a formal language developed by Labri and adopted by many industrial.
Yes, AltaRica is a language that was created some 20 years ago, so first version by the Labri. So it's from the University of Bordeaux. And then there have been some modifications to the language into demands from the industry, but it's still an outside language. It's not a language from Apsys or from SimfiaNeo. And so it already has a grammar existing outside from us.
Okay, thanks. Second question. Did you use an open source library or solution to import the Capella model?
Yes, we used EMF coevolution, which does the job. We don't have an intermediate meta model. We use the Capella meta model as is.
Is there a one-to-one mapping between the SimfiaNeo model and an AltaRica code base?
There are some, we didn't show it in the session, but we have more concepts on the AltaRica language. There are concepts to design FHA assessment, which does not have AltaRica.
And aside from this, all the graphical layout is not part of AltaRica at all.
Yes.
Okay, thanks. And okay, maybe a bit provocative one. Why did you consider AltaRica? Is it better than to use the B method?
I do not know very well the B method, so I would not like to say some mistakes, some errors. From what I know, AltaRica language was designed 20 years ago specifically for dependability studies, for this kind of studies. So I guess experts from this time, I was not here 20 years ago, but they were, of course, they knew about the B, and I think they knew about some limitations for the kind of questions that we have to answer also for authorities on these aspects. But again, I do not know really well the B method, so I'm not able to tell you the differences between the two.